Hello Year 8 and welcome to your next module, the air around us. Over the page you should find some of the targets we'd like to try and get through in this module. Have a read through if you're interested. The close the gap marking sheet you should have seen before. You will do more of that towards the end of the module. Okay, lesson 1. Have a think about what we need to survive. There are some very simple basic things we need to survive. Okay, you need water, you need food, and because you're a lot of teenagers, you probably need Wi-Fi as well, or we cannot survive. What are some other things you need to survive? Pause the video now and have a think, see if you can fill out some more stuff in the boxes without which you cannot survive. Pause the video now. I'm hoping you've come up with some of your own answers for that, but here's some that I've come up with. Okay. Clothing. Without clothing you're going to get cold rather quickly. You're going to be exposed to the elements. Shelter. Again, protect you from the elements, keep you warm, keep you dry. Gives you protection. Sleep. Every day. Friends. We are sociable animals, sociable beings. We need friends. Family who love us. Care for us, protect us, safety in numbers. You need all of these to survive, but you've only got minutes if you don't have air. So air is one of the things we definitely need to survive, but what is in it? That's what this module is going to look at. The air around us and what is in it that we need to survive. So if you can think, do you know what the one thing is that's in air that you need to survive is? Have a think. It is, of course, oxygen. So where does oxygen come from? Do you know? Oxygen supports the burning of gases through blank. This produces the gas blank. In our bodies we produce carbon dioxide by blank. We remove this gas from our bodies by the exchange of gases in our lungs known as blank. Fill out those missing words. So, oxygen supports the burning of fuels through combustion. This produces the gas carbon dioxide. In our bodies we produce carbon dioxide by respiration. Remove these gases from our lungs by breathing. Remember that from the oxygen molecule. So we're going to be talking about oxygen, so we're going to make it first. So, in nature it is made by living things, by plants. Okay, that process is called photosynthesis, where it takes carbon dioxide and breaks it down from the carbon and the oxygen within it into the carbon, which is absorbed by the plant. That's how you make it grow, and the oxygen, which is then released into the environment. So photosynthesis in nature will break down carbon dioxide into carbon and oxygen. Carbon is absorbed by the plant and the oxygen is released to the atmosphere. In a lab we can do something similar. We can take water, okay, and using a process called electrolysis, we can take water, which is hydrogen and oxygen, and we pass electricity through it, and that will break it up into the hydrogen and the oxygen. So we take water, H2O, and by electrolysis we break it into the hydrogen and the oxygen. Okay, so in the lab we're going to do this slightly different way. We're going to take a thing called hydrogen peroxide. Now hydrogen peroxide is like water, but it's got extra oxygen added to it. Very much like your Coca-Cola drink. It is a liquid that's got carbon dioxide dissolved in it. Hydrogen peroxide is a water that's got extra oxygen dissolved in it. We're going to try and break it out. Okay, and that process is called decomposition. When something is broken down, starts to degrade, fall apart. Okay, we're going to break it down into water and oxygen gas. So H2O, but this has an extra O in it, and we're going to break it down into water and the extra oxygen. Okay, we're going to use a thing called a catalyst to achieve that. The catalyst we're going to use is a substance called manganese oxide. Have we all done the peppermint experiment, the Mentos in Coke? where you put Mentos into a bottle of Coke and the bottle ejects all of its liquid and gas in one go. It's like that.
All right.
Now, when we pull it out, those are going to fall real fast, and when they do, all of the bubbles that are inside are going to rush to them, and we might see a little eruption. Are you ready? All right, so we're going to go 3, 2, 1, pull. Ready? Okay. 3, 2, 1, pull. Good. Ah! Tell me that that's not awesome.
This reaction won't be quite so dramatic, but we are going to break down the hydrogen and oxygen in hydrogen peroxide into water and separate out the oxygen. That's what we're going to do in this experiment. So we're going to decompose hydrogen peroxide. Here is the equipment we're going to use. So in your book you can label up each piece of equipment. We're going to have manganese oxide as our catalyst, much like the Mentos in the Coca-Cola. We're going to pour in hydrogen peroxide. That'll come down through the tube. It'll react with the manganese oxide and it will break down into water and oxygen. The oxygen gas will be collected by the side tube and deliver it down into a flask of water that's got an upside down boiling tube in it that is also full of water, and the oxygen gas will bubble down into here and bubble up and fill up this tube. To start with, this boiling tube and this delivery tube will be full of air. That air will be displaced by the oxygen, so the first tube we collect will have oxygen and air in it. Once we've done one tube, then all the air will be gone and it will just be pure oxygen we collect from then on. That's the plan.
Aeroendus lesson 1. In the bottom of our boiling tube we have 2 spatulas of manganese oxide. We're going to pour in 30 centimeters cubed of liquid hydrogen peroxide. This will react and strip the oxygen and hydrogen peroxide, then bubble along the tube and bubble it into the test tube. We're going to do this slowly. Maybe even slower than that. We now have 4 tubes filled with oxygen. The first tube will not be pure oxygen, as it also contains the air displaced out of the pipe at the start of the reaction. So the last 3 contain pure oxygen.
So in that experiment we put 2 spatulas of manganese oxide into the sidearm tube. That was going to act like the catalyst that starts the reaction, much like the Mentos fall into the Coca-Cola. 30 centimetres cubed of liquid hydrogen peroxide was added, and I slowly, not slowly enough as it turned out, poured the hydrogen peroxide into the thistle funnel and onto the manganese oxide. Collected 3 tubes, and we now have 3 tubes of oxygen. So, filling in the blanks. Pause the video now and complete the blanks. Also, why must the level of the hydrogen peroxide be above the bottom of this thistle funnel tube? Why must we fill it above this line? So, the liquid hydrogen peroxide reacted with the powdered magnesium oxide. As they started to fizz, the fizzing was the chemicals reacting and releasing oxygen gas. Okay. We had to keep this level above here to ensure the generated gas goes out the sidearm tube and not up the thistle funnel. Now we've collected our oxygen gas, what we think it is oxygen, let's prove it. So we've got to test for it. Oxygen is required for life, so we're going to use fire to test for it. So, safety first, goggles on at all times when you're doing these tests. So, first things first, what does oxygen look like? What do you expect it to look like? We're going to safely assess its smell, then we're going to recork. When we really assess the smell, we don't take the cork off a tube and then stick our noses in it and take a right good deep lung fill. That might be a bad idea. We shouldn't be giving you should never find it in the school that's that dangerous for you, but it could happen. On top of that, some things are quite smelly. You don't want a lung full of something that's going to make you feel quite ill and have to run to the toilet. So, when we safely assess the smell, we uncork something, we take a little whiff of the air around it, and then you might waft some of it towards you gently with your hand, and then again smell the air that is around it. We do not stick our noses into test tubes and take a good noseful. That's a bad idea. Then I'm going to test it with a lit splint and with a glowing splint. Now, oxygen should relight a glowing splint, and a lit splint will burn even brighter if there is oxygen present. That's the test. We're going to test it also with lime water, which should have no effect if it's oxygen. So here's the table. Let's watch a little video.
Testing ox for oxygen. These are the 3 tubes we collected earlier. Tube 1 we're going to test with a lit splint.
Here you go, to observe the tubes. It is a clear gas. There is no obvious effect that you can see that oxygen is present. Also, when you smell it, there is no smell to note. Notice the bright flame?
Notice the flame got brighter? I hope you did. As soon as it entered the tube. And it is relit by being in the tube and then glows brighter again. Tube 3.
And then shake
Clear.
it and show the after effect.
No effect.
So, the appearance. It is a colourless gas. It is an odourless gas. With a lighted splint, it will burn brighter. With a glowing splint, it will relight. And with lime water, it will have no effect. And that brings us to the end of lesson 1. So, next thing you've got to do is complete homework 1. That's your task for tonight. And we'll see you at the next lesson. Thank you very much.